Good morning, good afternoon, good evening, whatever time you are watching this. This is Sam Prentice Makes Things Happen. I'm Sam Prentice back once again, making it happen. And today we are looking at and going to be going through how to build one of the wacky racers or the track racers or the Murph racers, depending on kind of which direction you've come in on this and how you've managed to sort of find this video. So if you found this video before Murph and you've been sent a link, awesome. There's going to be loads of links in the description below on how to get this stuff. There's going to be a bill of materials and I'm going to go through how to build this right now. Now, if you've come in after Mirth, which is at the end of June, I believe, then there's going to be a different link to a Patreon site, and I think the files are going to be like $1 or something like that. It's going to be cheap, whichever way you look at it. So hope you enjoy the video. I'm going to go through exactly how to build these things, what they're all about, and hey, you know what? Let's get straight on into this, shall we? Here we go.
You are watching a master at work.
Okay, so the files we're going to be working on straight away are going to be drives A, drives B, and also the main frame. Now, in regards to the main frame, I am going to be printing it in this downwards configuration, so with this bit on the bed. You are going to see as well that there is going to be some bridging that's going to need to be done in this battery internal compartment here, certainly on the lulzbot and also the Prusa. Any quality printer will have no problems with doing these bridging points, so hopefully you'll have a well-tuned 3D printer in order also to do this kind of stuff. I wouldn't start putting any infill or supports or anything inside of that because it's going to be a real pain to get that out. But anyway, that's a relatively simple one. 20 to 30% PLA or PETG is generally what I've been using on this. And that's a really easy one to start off with. So drives A and drives B, basically these two are mirrored. So what you'll find here is you'll have a frame, which we'll be printing in this configuration. I wouldn't bother really putting in too much support. You can inside of these parts if you wish to. There's going to be some bearings that are going to be sat inside of here and also here and here. So if you want a nice smooth finish on that, that might be the route and the way forward for you. Let's have a look at what else we've got here. So we've got a frame part here as well. Again, very easy to print. This is where our motor is going to be sitting inside of. On the drive gear, again, relatively simple again. I usually print these in PETG just because there is going to be a slight wearing element on this. Although the plastics that we've been using with these types of drives have been, you know, pretty much flawless. We do also put a little bit of grease on the side of these as well, just to make sure that the friction is sort of kept down and maintained. On the inner wheels, we're going to be printing two of these, and again, the drive gear will eventually connect to the inner wheel and spin these. We print two of these because there's no point in just removing this gearing because it's, you know, seamless anyway. And if something was to break or a point of these were to break, you could always swap it over with the rear one. So it just makes it easy for maneuverability, I guess. And again, we're going to be printing it in that configuration, two of those, and the same with the outer wheel as well. The bit that becomes a little bit tricky is the actual tracks. Now these are printed usually, or certainly from my preferences, on Polymaker 95 fast flow TPU. So I normally have 4 or 5 layers and then 5% on the internals. We are going to be printing it in this configuration here. And of course we need 30 of these on each side. Now, depending on what 3D printer you've got again, and if you're worried about possible big failures on a relatively expensive TPU profile, you can print these in 10s, you can print these in singles. Each one of these is around about an hour, so it does take a little while to get these things manufactured. So several hours later we do have some tracks that have now been finished, and you'll see at the top here there is some 2mm rod as well. We use this rod basically to join the tracks together, and you know what, here's one I made earlier. So this is 30 tracks on the side of that. They have been pinned together. I've left one pin in there, as you can see, which is actually slightly longer. You can, of course, measure them, but what I choose to do is I insert that all the way, then I pull it back just a tiny bit, and then I'll get a pair of pliers and then just snip the ends off. I then knock the little metal parts back into the body. Make sure you do leave at least one of these slightly longer and slightly out, so if you ever choose to sort of remove the tracks, then you can obviously knock those back. And here's me just demonstrating how the 2mm rod just goes straight in just like that. And again, all we do is we just pull it back ever so slightly, just a few mil, just like that, and take your pliers, snip away. Obviously you may choose to do this in a slightly different way, and these come in around about 5.5 centimeters, and you can measure that and then obviously cut the rod to the size that you require. So we're now going to start assembling the framework. Now you're going to need 8 6202 RS bearings. These are 15-24-5 bearings. I'll pop some links in the BOM so you can find those straight away. And all we're going to do is basically just drop these in and just make sure that everything does fit. Now, just a little word of warning here. This is just a test fit. I'm just going to make sure that everything fits in there together and all snugly. And the reason I'm doing that is because if there is any variances on the print, or if the print has warped in any way, then I'm going to be able to quickly see that and solve that before we get any further into it. Once you've installed a motor and you're trying to mount everything together, from experience, this is kind of a better way of doing it, or certainly my preferred way to do it. You don't have to do this, it's entirely up to you, but I figured it's worth just popping it in and just showing you how this works. So for all intents and purposes here, you can use a drill if you want to. Just be very careful you don't rip the prints to shreds by threading these in. And you'll notice here that these are quite short screws. The reason for that is, again, we're just doing some retrofit tests now just to make sure that everything goes together just as well. So what I'm looking for here is there going to be any lifting or any abnormalities on that drive wheel? It doesn't seem to be, so we're going to whip the track apart now, removing the slightly longer pin, and we're just going to pin this back together. What I found with joining these things up, because there is obviously not much slack in these tracks, you can sort of move and manipulate the track around or put it on over the wheel and then basically just knock that pin straight on in, which I seem to be struggling with right now. But we got there just about in the end. Again, there you go. Job's a good one. From a safety aspect, I'm just going to run my fingers along the internals of the track. Just want to make sure that none of these things are sticking out. I don't really want this, you know, crashing into a child and maiming them in some way. So just make sure that they're nicely tucked away. So next up we have the 2 drive gears, which I said before was printed in PETG. You are also going to need, there you go, a couple of those screws. If the screws are slightly too long, then you can of course cut them down, which is something that I've become quite efficient at doing. And then you get the screw into your sort of size. Again, you know, there's tolerances on these prints. What you don't want to do is you don't want it piercing through the print. So if you just nip those off after measuring them, you should be absolutely fine. So the flange couplings are next. They're 2 6mm inner diameter. These are H12 by D10 rigid flange couplings, again, which are also bought on Amazon. You do need to get the 6mm ones because obviously you want it to fit the motor, and the Pololu motors are 6mm on their shafts. So hopefully what you can see in my hand is actually the grub screws. Now these grub screws are a bit of a pain. You can change them out if you want to, or what I've done in this case is I've used some Loctite in order to make sure that those grub screws do not come loose. Again, we are going to be thrashing around and crashing these things about, so making sure that they are adequately in there and are not going to kind of make or break. That's going to be the aim of the game with this. Now you will be able to get to those grub screws. The way that the motor is mounted, you can just get a little Torx in there just to nip it up if needed, but if you do this right first time, you shouldn't have any issues. So each of these couplers take 3mm screws. They're around about 3 to 4mm, but that needs to sort of bite just internally there. I think these are 6mm overall. I'm just going to nip that straight in there. You can, of course, you know, open these up a little bit if required, and sometimes that's what I do because they are a little bit fiddly trying to get the tiny little screws in there, and that's what I've done in this instance anyway. And then just nip it up just so it's biting, just like that. So we need to do that 4 times on each of these, and obviously we only just use 1 per drive motor. So the motors that we have been using are the 1:10 ratio Pololu motors. In this case though, I have decided to try and use a different type of motor, which at the end of this is actually not a great motor at all. They do move, but there's just no torque to them. You can see that the motor is actually a lot smaller. I do actually put these into this racer, but they're just not good enough. You want at least 1000 RPM, you want a decent torque ratio, and ultimately for this particular part you're going to want some sort of quality. So I'm just going to whip the grub screws in there now. Again, I'm going to be using some Loctite on this. Ironically though, I do take this motor apart, so you know, Loctite as you will. So I'm never going to win any awards for soldering, but I do put 2 cables onto this little DC motor. They're 12 volt cables. Actually, I've recovered these from my work. There was some computers there that I've basically just ripped the cabling out of. So I know they're going to be good for 12 volt. The other thing you need to do is probably heat shrink those parts as well, and I do that a little bit later on. This is basically just to demonstrate how the grub screw goes in and how the Loctite goes on as well. There are 2 grub screws on these ones. You might get one that's just got 1 on it, or you might have one that has 4 on it, but this one has 2. So Loctite that little sucker into there, and like I say, you shouldn't have too many issues with these things coming undone. In other models that we've made and done over the I don't know, the last 12-18 months, the grub screws do tend to come out of these things. So you know, that's why I'm hamming this one up. I guess if you're going to take any advice from this video, just make sure that you do this one bit, because you'll be thanking me. Well, you won't be thanking me if they come undone and I didn't mention it. So there you go. Whip him straight in there. And these things are a little bit kind of like glue. It just makes sure that that screw doesn't move. You can still take them in and out, and you may need to do that. I certainly do that later on in this video, but they haven't moved since, and I've thrashed them around like crazy since. So there you go. Another quick safety tip here. Just be careful with tools. You can see on my finger I managed to, I think I gouged either a piece of 3D printed part or I don't know, a screwdriver or something into my finger earlier on in the video. So just be a little bit careful. Make sure there's an adult that's supervising you at all times, and maybe get yourself a box of plasters, because that's a bit grim. There's the Loctite, and again, like I say, grub screws, Loctite. It's the way forward, 100% the way forward. So as I said previously, there is a little bit of having to undo screws and put things in and all that kind of stuff. It's part of the game really. So what I do here is basically just take the drive motor elements off so I can actually slip the gears in. It's the only real way of doing this. You do have to take these parts off, unfortunately, but it is relatively easy to put these bits back in again. All we do is slip those in, and you'll see that there are 3 screws at the top there. You should have that if you printed the left and right correctly. You should have that on both sides, and then you can basically fire the screws straight on in, just like that. So let's just check a few things. Let's grab the frame and just make sure these are all going to line up and fit in correctly. You'll see on the side here, that's where the cables do pop through. Just working out which way and which direction this is all going to go into. The bit with the D shape, the larger D shape at the front, that is actually the front. I was just working out here whether or not I was going to have this rear wheel driven or front wheel driven. Generally for most of these models I've had them in the front wheel drive configuration. As it's a tank, it doesn't really matter. Plus I guess you've got a little bit more weight coming forward that way, which might be evened up with the battery, you never know. So all I'm going to make sure here is that actually all these things are together. Undo a few more things, put some more things together, and just make sure that everything is lined up at this particular point. It would have helped if I'd labelled some stuff, so popping these things back in and just making sure that everything lines up is certainly key. So I'm just going to speed this up because it is essentially me just screwing some screws in to this framework. As you can see, you know, the wheel will essentially go on the external part of this, not on the internal part, and you'll see that in just in a second there. Everything fits in together very, very nicely, and then as you turn that particular part, you'll see that the internal motors are moving around as well. Now, in regards to kind of length and distance, if you pop that drive shaft on there, you shouldn't have to mess around with it at all, but the fact that you can get to those grub screws will mean that you can pull it forward if you need to. And just like that, friends, you should have something that ends up looking like this. And you'll also know if this is going to be ran the right way, because if you flip the framework over, it won't allow you to sort of screw any of the screws in. It will come out of misaligned and stuff. So definitely front wheel drive is definitely the way to go. And all you need to do is just make sure you're matching up the screws. The side parts here are where you're going to put your wires through. And all we're going to do here is just pull the cables through to the front. So when we mount everything, it'll all be there ready to go. So we've got 12 screws to mount the framework to the drive motors. Very, very quick, very simple. We're going to whip the tracks back on now, pulling the pins, popping them around, and again, like I say, I do ideally like to make sure we get some grease in at this particular point, and just run those in, just so we get that movement working. We don't really want too much friction across that if we can help it. Whip the pins in. Now I do these internally rather than externally, again because I don't really want a pin coming out and it maiming somebody as I crash into their feet or something. So it's a good safety measure there. Just making sure everything's all together and it feels all nice and tight, and it is. Right then, friends, next we're going to be moving on to electronics and wiring. As you already know, you've installed the two DC motors which essentially run left and right. Basically, the way forward for this is probably by stripping back the cables. You can use ferrules. I know it's very, very popular in 3D printing. However, I'm not going to use ferrules. I'm just going to plug it straight into this Cytron board. Now, this Cytron board is actually quite unique because it is a radio controlled version. There are various different types that can be Arduino controlled or dual Arduino and RC. This one in particular is the Model 10. It's a 10 amp, I believe, with two motor drivers, and then obviously the internals that I think the voltage goes from 7 volts up to 32 volts. It's quite a powerful little motor driver. And from my experience with working with these things, they are very, very good, and I've not had one go wrong so far, touch wood. So you don't have to use the Cytron version. You can just use a any kind of speed controller that does forward and reverse. The motor voltage on this is 7 volts to 30 volts. Maximum peak is 30 amp at the peak and 10 amp continuous. There's a bunch of LEDs and bits and pieces there. Check the wiring and make sure the battery polarity is correct before popping it in. It is a regenerative motor driver. This basically means that if you move this along, if you push this along, it will generate power back into the motor. So you've got to be a little bit careful. It does have over voltage protection, which might be triggered if you're not careful with that. And it talks about a shunt regulator running in parallel with the power input, switching the power supply, etc, etc. So like I said before, this is the MDD-RC10, and again, all you need to do is add your RC controller, your battery and your left and right motors to this particular device. It has got tank control built in, I believe, as well. And while we're on the topic of power, this is the battery that I am using, and I'm going to give you some measurements now because this has got to go back into the battery compartment at the back, and it is super, super snug. So we are looking at 3.5 centimeters by 3.2 by around about 11. And that fits very, very snugly into the bottom. Just be really careful when you're putting these things in. Don't charge it internally there, because if you do and it swells up, you may not be able to get the thing back out again. So just be so, so careful with LiPo batteries. So just measuring this again, it is snug. So, so snug, especially on that particular part. That isn't so bad. You can still pull cables through, but we'll just pop that in there now. And I wouldn't put it in this way. I'm just demonstrating that it can go in. It is snug. I'm not going to lie. It's very, very snug. But it does go in. And you give it a little push down and it will sit in there nicely. It's only snug through that particular part, mind you. So you can run cables at the top. You can put them through the bottom. It very much depends on what your sort of cabling preferences are going to be. And if you decide to add things like LED lighting and stuff like that, little servos or anything else internally into this, it might be a consideration that you might want to think about. The battery connection on this is called an XT60. Now, we will want to bridge this later on because there is also another part that we need to add into where the switch deactivates from the head, but we're going to just test this for now. Now, I don't want to completely blow your mind here, and I'm going to go through this reasonably quickly, but there are actually another couple of servos that basically move the arms backwards and forwards if you're going forward or backwards or left and right. The other servo, of course, is in the rear, which is a 25 kilo or up to 35 kilo servo, which activates the boom. So what we're actually going to do here is I'm going to twin the outputs for the data. So the data cables are actually the white cables. So all I'm going to do here is basically make a three-way split on two of those cables, which means that when I push forward, the arm will move forward. When I push left and right, the arm will move left and right or forward and backwards as and when it sees fit. The other thing that I've done here is I've plugged the power, so the positive and negative, the blue and the black here, into other ports. So there is kind of electricity that's evenly spread, not just going to the board, but also then going to the servo motors. And I've found that this particular way makes it a little bit more responsive, and it's not going to pull down on the power too much. And it seems to work very, very well. So all I do here is I basically look to start twisting the cables together. And again, like I say, in the BOM there will be a wiring diagram on how to do this. But as I say, this way that I've done it, it seems to be very, very effective. You can buy a pre-made loom. And again, it's down to your preference on whether or not you want to do that. So the other thing with that, I guess, would be that your power probably will come off the same port as well. So you might get a little bit of glitching. But the way that I've done this is relatively simple. Certainly the simplest place that I could possibly do it. So make sure you check out the BOM on that, and hopefully this will suffice. So just off camera, I wired in the and soldered up the XT60 cable. Don't do it the way that I've done this. Make sure you've got your positive and negative colour coordinated as well. Don't just use 2 black wires. Unfortunately, I ran out of wires, so I needed to just double check and make sure that I was plugging the right things into the to the right ports. Again, going wrong on this is going to be a bit of a catastrophe. So just make sure that everything's plugged in nicely. And all we're going to do here is plug these two together, and fingers crossed you get some flashing lights, and away we go. Now, on the unit itself, there are 4 little buttons, so you can actually make the unit go forward and backwards and test your motors that way. And obviously the controllers there as well. So if I push these buttons here, you can see it's going backwards and forwards, and then we can sort of reconfigure those and mess around a little bit. So that's pretty good. I think on that left hand side there was a little bit of noise coming out of it, and you can see there's a slight wonk on the print. So I don't know why that's happened, but you know, just keep an eye out for that, and just make sure that your prints are nice and flat. So I popped everything in together, and I quickly bound the radio to the receiver. I'm using an orange receiver with a Spectrum RC. And yeah, I think everything's pretty much where it needs to be. Let's have a look. Forward, backwards. I think left and right. Yeah, it's not too bad. Now, I did feel like these motors were a little bit slow, and I wouldn't suggest buying these particular ones, but the Palolo ones are certainly much better and much more efficient. So let's jump back into printed parts. We're going to be working on the front frame now, and this is a relatively simple part. This is the arm frame, and we'll come on to what that does in a couple of minutes. You've got brackets A and brackets B, which basically hold the front of the carriage to the rear of the carriage. This is the drive console, so across here and across here will be where the arm movements will be made. The front bracket goes right at the very front of the unit. That's actually onto the main kind of carriage and the main frame STL that we worked on earlier. Now this is the very front, so that basically sits on top of that frame area here, and inside of here is basically where the servos are going to go, and also that arm frame basically goes in the top of this as well. Front grille, you can customize that if you want. This is the left drive lever, so as the servos move back and forth, this is basically how this is going to go through, and the arms basically connect to that, and it has a nice kind of movement going up and down there. Front headlight, nothing too sort of flash about this really. You can do these in whatever colour you like and whack an LED in there if you see fit to. This goes over the servo arm and basically drives the one of the levers here, and you've got a left, you've got a right, another light of course, and then the servo frame. So your servos will sit here and here. The servo actually, the positioning actually goes towards the top here, and that basically slots inside of this. So that sits very neatly inside of that, and then of course the arm frame then sits on top of that as well. So let's get into that then. And just like that, we have a print. As you can see on the middle part, which is the servo arms, I have mounted them in the upward position. I'm just going to fix those with the screws that actually came with the servo. So eventually all 3 of these parts will actually merge together, and I'll just show you how to do that in just a few minutes once we've whipped these servos on. Just be careful with the screws on this, because you don't want to be breaking the plastic, because otherwise you might have to reprint it or glue it or mess about with a ton of things. So just be really careful when you're screwing those in. The servo arms also come with these as well. They're just the drip ones, and you can kick the rest into a little bag and probably dispose of those. And then I'm just going to pop those on there for the moment. I will take them on and off throughout the video, because I will also be greasing the little shaft that these sit in. And also when I put the console on top, I normally have to kind of sand it back a little bit, so you just get a nice fluid motion on the arm movements. At this point as well, if you put everything together and you screw everything down, you're not going to know where the positioning is of the servo. So it's always best to plug these in, but then don't fully screw down the servo connectors until you've plugged everything back in again and you've got some power running to it. So in the bottom of that, I just basically took out a couple of little bits of support, and we're going to whack 3 screws into that in a moment. Then adding the joining brackets so we can get the kind of middle section of the racer put together. There's a few little bits here you want to probably do by hand because the drill is going to be a little bit over the top for these parts because they're quite delicate. So just be really careful with how you put these in. And that'll give you a nice sort of steady frame to work off at this particular point. Okay, so let's head back to rear bike now. And you'll see a few files here. I just want to go through what they are. This is basically just a detail that goes on the back of the unit. There's a magnet bracket that I don't actually use this, but this would be used basically to hold the racer in place. I think it's a little bit more fun if he's a bit more loose. This is the main fin. Now, we've got a new version of this. This will basically turn 180 degrees and swing arm out left and right. Whereas the new one we've got, basically the servo comes in at the back and it drops down to the left and it drops down to the right. And I'll show that in my next video. But for right now, I'm going to continue to carry on making... It works perfectly fine. It's just more of a pain if there's a bit of drag with this unit behind it. So I just wanted to change that up a little bit. We've done the rear frame. Obviously, you've seen that picture. You've seen the fact that we've just joined these parts on here. Your seat and everything gets mounted onto the back here, and of course then the main fin gets mounted on top of here. Your servo plugs get pushed through here, and again there's a few nice little details and stuff here. On the back there are kind of like little jets, and there's a panel that you basically just slide straight up into here just to hide your batteries away and everything. The rear jets are here. It's this little one here, and another one there. You can again customize it to however you want. The rear panel, there's a little insert that goes inside of here just so you've got a bit of airflow or any heat can escape from this particular part. There's a clip that goes onto the back of that, which is just based down here. That's the clip that goes inside of that. Now the seat for the one I'm making at the moment, I've actually done this in TPU. There's no reason to do it in TPU. I just had some, it was on the printer, so I thought, you know what, I'm just going to print it in TPU. So that's easy, and this is the seat base. So the seat will sit on the top of the seat base, and the top fin basically hides the parts of the servo that you don't really want people to see. And the swing arm just basically comes out to here. So let's have a look at that. So let's mount where the swing arm and the servos are going to be placed into. Again, there's a couple of little bits here that I just need to take off. Nothing too sort of over the top as that falls off. So that's basically me explaining how the swing arm's going to work. And as I say, we're going to do this drop one. You can do either one. It doesn't really matter. It's entirely up to you. And, you know, we'll give you both versions in any case. Like I say, there is a magnet that can go into this. I have provided the STL with the magnet, and I'm going to put a magnet in it. But to be honest with you, I'm not going to use that. And I think basically you put one inside of the racer, actually the robot himself, and then you put one in there. They're obviously negative poles, so it just holds him slightly in place so he doesn't sort of fly off. However, I haven't had him fly off at all so far, so, you know, and I think it really adds to the fun. So this is the seat base. This is the seat. Move him over. And we're just going to work on the servo part. So this is the fin that I was talking about. It's literally just an aesthetic. This is a 20 kilo servo. I've put 25s in, I've put 35s in, I've tested all these and they all work absolutely fine. Some of them, even though they're listed as 180 degrees, some of them don't quite go 180, and that isn't just a remote control issue, that's literally a servo issue. They do all come with these kind of metal swing arms as well, and basically all of these are basically made exactly the same. So you shouldn't have any kind of major issues with that. There is a bolt that goes in the top, and then you just need to put 2 M3 screws onto that. The rear panel and the heat vent do require a tiny piece of glue to be inserted. Leave that for a couple of minutes to one side while we work on some other bits and pieces. On the bottom of this, again, there is a little notch that you can put in. Sometimes they are so tight actually you don't need to put anything in there at all, but if you want to put that on there, of course you can, and it won't make too much of a difference, but it does slide in there very nicely either way. So yeah, you could always put a couple of screws in there, but just be very, very careful not to knock the battery or pierce the battery in any way, because you'll be in a whole world of hurt. Right, then next we're just going to be working on those little servo motors. And I've already pre-plugged these in. Again, if you check the BOM, I'll give you some information on which ports to plug these into. It might differ depending on what RC gear you're using, how many channels and all that kind of crazy stuff, but generally it's going to be all the same. You want your right hand controller to be going forward and backwards, left and right, and then basically off the side of that, then we just take that on. So I've just added that up, plugged it on in, and as you can see already, it's already got fluid motion. I'm going to whip a bit of grease just in there as well, just so that nothing gets jammed, because these servos are quite precious. So if they do get stuck for too long, they are quite likely to burn out. They are very, very cheap servos. I think these ones are the metal internal servos. They tend to be a little bit better, a little bit more resilient than the plastic ones, but you know, the results will very much be the same. Now, as you can see on the back there, I haven't quite got that full motion yet, and there's a number of reasons for that. And if I don't end up getting the full motion of that, I'm probably going to have to change the servo out, or upgrade that to a 270-degree servo instead. A couple of little additions to the back there. So hopefully that's going to get you part way through this build and certainly set you in good standing for the next couple of bits that I'm going to be putting out as well. The driver is obviously the next thing to do. I'm going to be looking at 3D rendering, changing the faces. How do we change the face? What does the colours look like, etc, etc. There are only a few more things to put on this particular one. So it's going to be the front, it's going to be the lighting as well, and obviously then we're just going to mount the guy on top. So that will be in my next video, which hopefully will be out in the next couple of days. I'm also going to be putting on the alternative swing arm. Basically that means that this part will be changed out, and instead of the servo being mounted on the top here, it's going to be mounted at the rear, and that will enable this then to go down to the left and down to the right, instead of having this boom that's basically going to be sticking out the back. So it will be sticking up like this. You can put a flag on it, you can do kind of pretty much whatever you like. You can put a couple of pretend heads on it if you wish. I don't know, it's up to you entirely, of course. If you've got any questions, any queries, any worries, any how do I do this, what components do I need, reach out to me. Facebook, Twitter, Instagram, you know, YouTube, whatever you like. I'm always free and available, so you know, hit me up, let me know if there's any problems. But happy building. I hope this is going to go well for you guys, and if I don't speak to you before, hopefully I'll see you at Murph. Take care, bye for now.
You are watching a master at work.